Hi, everyone. This is Shannon Williams from Rancher, and welcome to today's online meetup. We're going to be spending today talking about container logging, specifically some of the challenges around container logging, how to manage sort of your own private logging service for containers, introducing the concept of an Elq Stack, and really getting into the depth of what it's like to try and deal with logs when you have multiple containers spitting out logs on the same box. So should be a good conversation. We have a really big crowd. I think this is one of our biggest meetups we've had yet. But for those of you who don't know me, I'm one of the co-founders here at Rancher, and I run our marketing and field organization. So you can follow me on Twitter, or my co-founder Darren Shepard is on the call as well. Darren, you want to say hi?
Hello, everyone.
Darren's our chief architect, and together we do these meetups every month talking about different topics around managing containers and deploying applications using containers. You can find all sorts of recordings of previous ones on our YouTube page or under events on our website. Today we're also going to be joined by another member of our staff, Bill Maxwell, who runs our DevOps team. Bill was on our last meetup talking about how we use drone and how we build out our own CI pipeline. And he's going to be doing a lot of the talking today, talking about our approach to managing logs. Bill, you want to say hello?
Hi, how's it going?
Okay. So what I wanted to do just to help us get started, for anyone who hasn't attended one of these sessions before, but just to be really clear, this is a meetup, not a webinar. It is meant to be really interactive. It's as much for asking questions and sort of going off topic and getting into discussions as it is a one-way recording television show type of conversation. So, please, as you attend one of these, just keep in mind some of our basic goals and rules for a meetup. One, questions are really welcome. So here in the GoToMeeting platform, you can use the little question tab that's part of your right-hand side control plane. So just open that up, type in questions, and as you type them in, we'll be reading them out, or we may save them for a little time that's more appropriate if there's something coming up that's on that topic. But we'll be trying to answer all your questions over the course of the session. We may answer privately or publicly, but we'll try to get all these questions answered. So we're not going anywhere until all the questions are answered. So there's meetups. We try to get through all the core content in the first hour or so, and then we'll answer questions until everyone's questions are answered. Second, we're going to be demoing a lot. So these demos are live. There's no recordings. We demo on real systems with real software. So be prepared. Sometimes things take a little while. We may hit a snag, but we're just going to troubleshoot on the fly, show you what we're doing, and hopefully that allows you to understand what's happening behind the scenes. So if if we've had all sorts of fun things happen in the past where laptops have crashed in the middle of things, so bear with us. It's real, and that means things are going to sometimes go differently than expected. So hopefully everything will go really smoothly. Bill has made his sacrifices to the demo god, so I think we're in good shape. We will be trying to keep the slides to a minimum. We want to just use just enough slides to set the context and explain what these concepts mean. What is Rancher? What's an Elk Stack? What are some of the issues with actually handling logs and containers? But we will not be a lot of slides. So we want to spend as much time as we can, on the command line or in the UI talking about how to do stuff. And then, as always, we like to kind of send out shirts or stickers or things to people who attend and ask good questions, or maybe participate on Twitter. Always think these things are really quite different than your typical meetup or typical webinar, I should say. This is a really nice post from last time when we were doing one of these Rancher meetups, and a group of people that were watching it together in Netherlands were posting as their pizza came on Twitter the entire time, so which made I know at least some people very jealous because the pizza looked excellent. So in that spirit, we know people join this from literally all over the world at all times of day, so hopefully this time works. But what we're doing this time is we're going to send out shirts to the 10 best pictures that people post to Twitter kind of showing what you're doing and what's going on while you're participating in the meetup. So if you want one of our shirts, we've just finally gotten a big new reorder, so we've got a bunch of shirts to send out to people who have attended in the past, so keep your eyes on your mailbox. But we'll mail out some shirts to people who post about what they're doing. So please keep it PG, but otherwise we'd love to see what's going on out in the world while we're talking. Okay, so our agenda for today, we are going to cover, we're going to really cover two main topics. We're going to do a very quick overview of Rancher, just for people who don't know who we are and what we do. We'll kind of explain that really briefly, explain what Rancher as a product is, and then we're going to jump into Bill's session, and he's going to really talk about why logging is particularly interesting or unique with containers, what some of those challenges are. He'll go through a couple different options and explain some of the approaches that we've talked to users that are using, as well as some things that we considered for ourselves, and he'll introduce kind of the Elk Stack and what it is. And then from a demo perspective, we're really going to spend most of the time showing how to build out a scalable, resilient Elk platform on top of Docker and Rancher, so that using Docker Compose, you can build everything from Elasticsearch to Logstash to Logspout to Kibana, and run it as a service that can scale up at any different level depending on your requirements. If you haven't had a chance to read it, Bill actually posted a blog earlier this week that goes into a lot of depth. So if you feel like you miss anything, feel free to go take a look at the Rancher blog on our website, and you'll see some detailed description of some of what he's doing here as well. So all of this is going to be recorded, by the way. So we record these meetups, we post them on YouTube. So after the fact, if you feel like you missed something or you want to hear it again, just go back, pull it up. You can watch any section over again. Once we're finished with that, Darren is just going to give a quick update on a bunch of new features that have come into Rancher since we did the last meetup. We'll talk about LDAP and SSL and metadata and a number of other nice new features that have rolled in, and then we'll just finish on how to get started and answer any remaining questions you might have. So hopefully it'll be a quick session, but don't hesitate to ask questions. We'll be rolling as we do and interrupting with those questions as they make sense. Okay, so real quickly, for those of you who aren't familiar with Rancher, Rancher is an open source software platform that is used to build effectively a private container service. And if you're familiar with the concept of a public container service like Amazon's ECS or Google's container engine, Rancher is going to feel really familiar because effectively it is a platform that you download. It's available on GitHub. You just download it from our GitHub site or from our website and run it. And what it does is it ties together a number of capabilities to make it possible for teams to really manage and deploy containers on any infrastructure. And what that means is that Rancher handles a number of specific use cases, effectively how to consume resources from any computing platform, whether it's a public cloud or a private cloud or just virtual machines or bare metal servers or any type of infrastructure. As long as it can run Docker, run Linux machines, Rancher can consume that infrastructure and provide it to teams that are deploying applications using either Docker Compose or Kubernetes or the Docker CLI or any kind of container orchestration. So and then all of that gets exposed through APIs to your DevOps tools to pull and manage these environments. And what makes all this possible is a lot of the work we've done in the platform. So we handle things like connecting users to the access control and authentication systems. We allow you to define different types of roles so that people are able to see containers or change containers or deploy containers. We also implement these container orchestration frameworks like Docker Compose and Kubernetes and Swarm as multi-tenant services. So, each environment can be deployed with the appropriate container orchestration for the type of application getting deployed. The real challenge, though, is actually the bottom piece, which is how to consume resources from sometimes very different platforms consistently, so that not only does the application template and the application image a portable thing, because of Docker and things like Compose and Kubernetes, but also the infrastructure is consistent. So we provide a full implementation of software-defined networking, container load balancing, host management, persistent storage, all for containers. And because of that, when you deploy an application, you're able to define the entire network architecture, the backup policies, the load balancing configuration, and have that be as portable as the Docker container itself. And then all of this gets exposed just through the Docker API. So Rancher doesn't introduce a new API; it effectively uses the same Docker commands you'd be familiar with, so that anything that integrates with Docker and can talk Docker, like Jenkins or Chef or Ansible or Sysdig or anything else, works cleanly with Rancher. So effectively, the container service then, once it's deployed, it allows users to go and create environments that are made up of resources from any cloud or host, and then provision containers or provision clusters or provision entire application stacks using either just native Docker commands or Docker Compose or Kubernetes. And that's really the value of the system. It's a full orchestration and management system for containers. And as you kind of drill into these environments, what you see is that the resources can come from anywhere, from any host, as long as it's running Docker, so it's a Linux machine, and running the Rancher agent. And then as they deploy containers, things like the networking, service discovery, load balancing, health checks are all implemented consistently across this. Even you can even connect networks that are on different clouds or in different data centers using the IPsec-based private networking. And then as you start to move into storage and do things like backup and recovery, Rancher tools like Convoy that we just announced a couple weeks ago allow you to start taking snapshots and recovering those, and you'll start to see this all come together into Rancher over the next few months, so that whether you're using just Docker Run, or you're using Compose and Kubernetes like we're going to show today, you can deploy any application anywhere and expect that it will function, consistently. So that's sort of what role Rancher plays. And in today's conversation, we're going to talk a little bit about how using Rancher and Docker together, you can deploy a container management or a container logging platform for monitoring any application that you deploy in containers wherever you deploy it. So with that, I want to turn things over to Bill, and Bill will get us started talking about how we've some of the challenges and issues with setting up containers. So Bill, I'm going to make you the presenter, and you can share your presentation. Bill, I think you might have been muted. I'm going to unmute you. Are you still there?
Yeah, I'm here. Can you hear me?
Yep, can hear you now. Okay, go ahead.
Great. Are you able to see my screen?
I can, yeah. I'm seeing the presentation. So if you just want to hit play, we can see that. We'll be able to see it. There you go.
Okay. Are you seeing it in the presenter view?
Now I am, yeah.
Okay. Cool. So collecting logs on containers. What we're going to be looking at today is just kind of how things were managed before, and then kind of the trouble or challenges that Docker or containerized environments present with logging, and some common approaches that have been taken. And then kind of one of the common log management systems that's kind of emerged is the Elk Stack. So we'll take a look at running the Elk Stack, and we'll be running it with Docker Compose on top of Rancher. And kind of the reason that we want to do this is you visualize and monitor and react to things that are going on in our environment. We want to see response codes from our front-end web servers and back-end servers, and really just sort of have that view, and then be able to deep dive into kind of issues as they arise. So diving into which servers, which role, which container, which version, and really get at our logs. As applications have gotten larger and span multiple servers and environments, it's become really common to kind of centralize and have these types of tools. And so kind of traditionally, with server management, you've got like a VM or a server, it's running your apps, you have a syslog, and everyone's kind of centralized on the host and is logging into var log, and for debugging purposes, you can jump onto the box and grep through logs and take a look at things, and you can ship those logs off to a remote system. Kind of the Elq Stacks existed for a while, so you've been able to do this for some some time, send your logs off into Elasticsearch, or some people send them to Hadoop or the third-party services for analysis. So it's not new, but it was kind of manageable and sort of understood problem, and configuration management tools kind of made this pretty simple to deal with, at least at the host level. But then with containers, you end up, on the box, these logs are kind of everywhere. They're isolated from the central box, so when you jump on the host, you can't necessarily see all the logs in a centralized place. They could be logging inside the container. Docker by default wants to standard out, standard error, and you can use the docker logs command to kind of parse through those. So you just kind of multiplies the problem on a host, and sort of, how do you get them central again so that you can use that data and feed it into other systems. And so there's kind of three main approaches to this problem that have been taken, and there's a lot of variants on each of them, but we'll kind of talk about the main points. But kind of logging to a common volume or place on the host. Then there's which basically, you kind of pull the logs out of the containers, put them someplace on the host so that your host systems can kind of work through them. Then logging sidekicks and forwarders. You can launch a container that shares a volume that logs, but then runs syslog or some forwarder to ship the logs off to a system. And then kind of newer on the block is the Docker logging drivers. And Docker now supports kind of, in addition to the default JSON file, can now export those logs through a couple of different formats. And so, logging to a common volume, you're bind mounting a volume into your containers, or you have a volume from, and then sharing a common, kind of like a data volume container to someplace on the host. The pros of this is, it centralizes the logs again back on the host, and you can kind of use your older tools to do the host tools to do log rotate and sort of manage them at the host level. And then you can do what you normally do, with shipping them off. If your applications were logging to this volume, but they aren't logging like standard error, standard out, you kind of lose that ability to jump on a box and look at the container logs for debugging. And it's sort of environment specific, so you lose some of that portability. Logging forwarders and sidekicks, and these approaches, you do kind of create a container that runs either syslog or presents a volume that does something with the logs to kind of parse and send them out. It kind of gives you the portability because both systems are in containers, so wherever they go, they're able to, anywhere you're running Docker, you're able to kind of run your logging infrastructure with it. But it does come with the expense that you're maybe not necessarily rotating your logs easily. You still have to kind of manage that and where they're going. You could be logging to two places. So there's that challenge with this. And then looking now at the Docker native drivers, these are pretty neat. Here you can still log to kind of the common JSON file that has been in Docker for some time now. But they've also added syslog. Actually, Rancher's been involved with that. Guelph and FluentD, and so with those you can wire them directly to send them to your log exporters. It's kind of nice that each container could use a different one if you wanted to. And this kind of gives you the ability, you now just have Docker, and so you have that one process and that one configuration. You can log remotely, locally. The one downside is, again, you can't just jump on a host to do a Docker logs to see, what's going on, and that's, in our experience, been pretty valuable just to be able to kind of, for debugging purposes, at least in like a dev test scenario. So kind of we've been talking about that, and then a lot of these solutions sort of focus on trying to get the logs from a host to some other system. And a common one that's really emerged is the Elk Stack, which is composed of Elasticsearch, which is a document database that provides really powerful indexing and search capabilities. And then Logstash, which is built to its purpose is to take logs from multiple sources, kind of massage them and tweak them into various outputs, and just kind of facilitates that movement from sources to their ultimate final destinations. And then a really popular tool is the Kibana, which allows you to visualize your logs coming out of Elasticsearch. When you see fancy log graphs, a lot of times they're done with this tool. And so just kind of looking at the pipeline and kind of how that looks visually, it's really made up of three kind of main components. You have Logstash, Elasticsearch, and Kibana, and they're discrete. When we first got started with the Elk Stack here, we were actually using a hosted version of Elasticsearch, which provided Kibana. We were just sort of running our own Logstash pipeline to get it from our log sources to kind of ship it off. But each one kind of has its own value, and they have their own operational concerns and the ability to, they have different scaling needs and the way you kind of want to process that. So as we get into our demo, we're going to be looking this is how we decided to break out the application, the stack. We looked at taking each one of these components and figuring out what it needs to kind of operate on its own. And so we're still working through that, but it's we do have a working demo, and we're pretty excited actually to show it to you. So with that, it's demo time. I do want to say that we did run into an issue.
Before you jump into this, there were a couple questions that came up, and I think it'd be helpful to explain when you talked about deploying each of these as separate services, and what role does Compose play in defining these these components of the Elk Stack. So maybe can you just talk about that a bit, and how you're going to actually deploy this?
Yeah, so each one of these ends up being its own Docker Compose file, and then each one of those is made up of their own discrete services. So what this does is it kind of separates them out for us so that we can kind of operationally and just from a context perspective, it makes it easier to reproduce the discrete parts of the application. So if you had like a centralized Elasticsearch cluster and you wanted to have you wanted to service multiple teams or groups in an organization, and you wanted to build discrete logging pipelines for each one, this kind of gives you that unit at which to reproduce it and kind of operate it at its own configuration. And so as we dive into this, what you'll see is kind of like, for instance, the Logstash is actually made up of 3 separate services: a collection tier, a queuing tier, and then an indexing kind of munging tier that it ships off the logs and is ultimately responsible for shipping them to Elasticsearch. And so when we see them in Rancher, what you'll see is we'll be running these all in a single environment, and each one will be its own stack. And within those stacks, you'll see that each one has a service, and we'll be able to link across these stacks so that the different components can talk to each other.
Got it. There was a question from Krishna Parvathanari who asked if in the demo you're going to use the Docker volumes approach. Is that how you're going to do it?
No, actually, in this demo, we're going to be using Logspout. We're going to be deploying that as a global service, and what that ends up doing, it's a tool from Glider Labs. It listens to the Docker daemon for events, and then when it gets one, it wires up a log stream that ships them off of the host to its target. I kind of like that approach just because the configuration ends up being a little lighter. But all of these are viable, and you can use the other approaches and use something to kind of take the logs directly. You could do a volume approach with like Logstash, reading from the files and sending them over, or some other tool like that.
Got it. Okay, great. Jawad Ekram asked, what is Gelf?
Gelf is a logging format / it's got its own stack of tools around that format that's been built. But for the purposes of what we're using it for, it's really just kind of a format that we can transport logs that Logstash understands, and a couple other systems that ingest logs and kind of ship and munge understand.
And where do you find it?
I think it's Gelf's Graylog, part of Graylog, I think.
Okay.
Graylog 2, maybe. I'll have to look.
I guess that's what Google's for. Okay. Why don't you jump into the demo? I think we've answered most of the questions that have come in, and any others will probably be able to cover a lot of it in the demo. So go for it.
All right. Okay. So I do want to say before we get started that as we were going through, we ran into a bug, and we're aware that these files running against the current latest version of Rancher has a hanging bug, but there's a bug fix that's underway and should be released shortly.
All right, sounds good.
In the next hour, so hopefully by the end of the meetup that you'll be able to get these files and try them out for yourself.
So just on that though, Bill, so the Docker files that you're going to be using to stand up each element of the stack, you're going to post those on to GitHub for people to download and try this themselves?
Yeah, they're on GitHub now. They're part of Rancher Compose templates.
Okay. So if you go to GitHub/Rancher/Compose templates, you'll see ones for Elasticsearch, Kibana, and Logstash.
Yes, yes, and
okay,
we have one for Logspout as well.
Okay, great.
So we're going to be. I have a pretty vanilla Rancher installation. We've got 3 nodes. We currently don't have any application stacks. So what we're going to be doing is using Rancher Compose to bring up these stacks. And so what I'll do is I'll bring up the stack, and while it's building, I will kind of walk through the Docker Compose file and sort of explain some of what we're doing under the hood here.
And Bill, which version of Docker are you using on the hosts?
These are all using Docker 182. Oh, yeah, 182.
All right, great.
Okay, so we'll do Rancher Compose -p, yes, up. These Compose files are using cross-stack linking, so these project names, when I give it the -p, they're actually significant. They can be changed. If you're going to use these files and you want to kind of customize them, I recommend you clone them and kind of make your local edits, and then you bring them up. And one of the variables is external links, and that's kind of how this gets set up. So just for the demo purpose, I'm going to stick to names that are currently in the files, but you can change them. So with that, we're bringing up the Elasticsearch Service, and let's take a look at the Compose file for that. So what we've done, the approach we've taken with Elasticsearch is, looking at their production guide and how to best run it, is there's 3 kind of distinct roles. There's the master servers, the data servers, and then the client servers. So the data servers are the ones that actually store the data and do all the heavy lifting, and then there's the master servers that sort of map out and know where everything is in the cluster, and then there's the client servers, which handle getting requests from external sources. In our case, like the Logstack, Kibana, and the COP monitoring tool. They all hit the clients, and the clients kind of farm out the requests to the rest of the cluster. And so with the approach we took kind of building each of these services is we built these Sidekick config containers. And what that means is, in Rancher, there's a concept of a sidekick, which is kind of an atomic scheduling unit. So if I say, this container is a sidekick of, container A is a sidekick of container B, wherever B goes, A will follow, O will be there with it, and we'll schedule them together. And this is really helpful for when doing things like volumes from, or if you're going to share a network namespace, or as you're kind of composing your application and your services with these containers, there's certain times where you want to share things with another container. And so in this case, we're using Conft, which is a tool built by Kelsey Hightower that reads from key value stores and then injects those values into template config files. So it's a really neat, lightweight configuration management tool that we have a lot of fun with. So this one's we're using the environment backend in this example. And so with these config containers, this configuration is specific for the master. And so here's the keys. We're setting a cluster name, a node name, whether it's a data master, the memory lock command, and then in our environment we don't have multicast, so we're going to set that to false, and we'll be handling it a different way. And so the config for the data nodes is a little different. It just kind of says that it's data. It's not supposed to be a master or a client. The client config kind of says the opposite of all of those. And so what you see here with these lines in the data and the client is that we're telling the unicast host these ES masters. And so when we deploy our data nodes, we're linking them together as ES masters. So that's the DNS entry. On the links, kind of Rancher is injecting, which is the same behavior as Docker, a DNS entry for those containers. And what this does is it allows us to use the unicast discovery mechanism for Elasticsearch, allowing it to allowing all the nodes to discover themselves. And so then the last container that we're adding outside of the clients is the COPS tool. This was something that when we were using Elastic Found they provided. I really liked it, and so I've added it to our stack. Let's see what's happened here while we were going through that file. Hopefully we have containers, and we do. And so if we can take a look at what we've got here. So this is our stack view, and so here you see we have the ES stack, and here's the different services that we brought up, and each one has two containers. One is the config, and one is the actual application. And so graph view, this is the config, which ends up reproducing the Docker file for you. But the graph view sort of shows what's happening in a nice way. So we have this Elasticsearch. These are the masters. You can see that they're linked together through this DNS entry. And so they kind of all wire up and discover each other. And then we have the Conf tool, which is a web-based tool that talks to the clients. So if we look at our compose, you can see the logs. They all kind of came up and discovered each other. But let's go take a look at the cluster. All went well. This will be available on port 80. We can see the logs scrolling by. And so this is a nice tool. It kind of lets you see that this is the indexes view. There's none created yet. We have 3 nodes, 0 shards. This kind of gives you a view of the nodes. If you want to look at a different view, this gives you the view of the masters and the clients. The data nodes, you can kind of see their heap usage and their disk space. So just to show that that's kind of working, let's scale our Elasticsearch data nodes to 2. We originally started with 1, now we're going up to 2. If we watch this, in a moment we should see a new node pop into the cluster. There we go. So now we have 2 data nodes that are in there. You can see kind of in the index view. This will end up showing where the shards are. But we now have a functioning Elasticsearch cluster. And so we started with the Elasticsearch because it's just kind of working from the bottom up the stack. So we have a place for our logs to go once we actually start shipping and moving them. So let's go take a look at, let's get Logstash up and running, because this will end up moving our logs from their sources into Elasticsearch. So we kind of need a pipeline for them. So we'll go ranger compose Logstash up. Okay, so that's going. You can see application view.
Hey, Bill, while this is all building up, there's a question that Andrew Kalick asked a little while ago. Who's asking, what the RAM requirements and maybe just in general what the compute requirements were for running all of this. It looked like you were running this on 3 hosts, 3 VMs that are running in, I think, Google Cloud, right?
Yes, yeah. So our environments, we have a lot of tooling around making it easy to spin up Google environments. So Elasticsearch is kind of, it likes RAM, a lot of it. So the more you can give it, the better. We're running it, I think, with the default heap size of a gig. But in this environment, since we're going to be running the full pipeline, there's a few Java processes. So Elasticsearch is a little bit big, so you want about 1 gigabyte at least, just to kind of get going with it. And then Logstash, you probably want probably like half a gig to a gig for that as well. And so the approach we're taking is a little bit more towards, like these would run kind of real workloads. So they're multi-tier and they're available. So the memory requirements for these are a little bit higher, but you could tweak the configurations and kind of get a small, more consolidated view where you didn't have the 3 roles, you had just kind of the 1, more for development purposes. And so then you could, kind of save on some of that RAM. But
And just to follow up, so is there a minimum number of hosts you would need to deploy this? Tuan Nguyen asked that question.
It will deploy to a single node, but with that, you can't deploy multiple data nodes. What we're doing is bind mounting the data volume for Elasticsearch from the host into it, into the container. And so when I first did it, we didn't do that. And so then when you would try and upgrade the cluster, there was it had to join the cluster, and sort of you had to like remove the node. And you had to wait till the index, like it got its shards and everything was kind of quiesced, and then like kind of remove one node and then let it rebalance. And so what we're doing is to address this is in a future release you'll be able to specify an in-place upgrade with the compose file. And so what that'll do is it'll shut down the node, bring up the new service, and bind mount in that data. So it'll look like, during the upgrade process, it'll look like that node, and there's no massive shuffling of data that has to happen. And so that's kind of the approach and the reasoning behind that.
On that topic then, 2 more questions, Bill. What type of instances are you actually running then in the Google host? What are those, can you pull that back up real fast to just show the amount of RAM and CPU and what you actually are running on your infrastructure stack?
Yeah, absolutely. These are just, I think these are the N1 standard. I believe they're single CPU with 4 gigs of RAM. And then
You're running 3 of those.
And we're running 3 of those. Yeah,
and thanks, Cole, for that question.
Yeah.
And then there was another question that was, what is the, this is a question from Tuan. He asked if the hosts need to share the same storage volume, or are we using any shared storage or anything between these hosts, or just whatever local disk they have?
No, we're just using the local disk that they have. And so there's no shared storage between the nodes. Elasticsearch actually handles the replication itself. So when you create an index in Elasticsearch terms, it creates a certain number of shards. And so once you kind of create that number of shards, it will kind of spin the data around those and then replicate them out across the hosts. And it tries to do a good job of balancing those. And so if you wanted to scale up, you can add up to the number of shards, primary shards, and you have 1 on each, and you get kind of that single performance. And then you're also limited in size to the maximum size that a single shard can grow on a host. You can create, after the fact, you can create additional read replicas, which help kind of speed up the read and search requests. And so you can keep adding nodes that way. And then I think if you needed to rebalance Elasticsearch, so if you had an index that just you had to break up into more, I believe it has the facility to recreate a new index based on that. But I believe it's a very time-consuming and expensive operation. You're reading through kind of and looking at Elasticsearch, there's a lot of kind of host-specific considerations to make when building and tuning a cluster that need to be looked at. And Elasticsearch actually has, or Elastic has a really good documentation around this and kind of the things to consider. I think their Elasticsearch in production documentation is kind of outlines what you'd be looking at there and kind of how to handle that.
Got it. There's a couple more questions. Well, I don't know if do you want to load up the last bit, the Logstash, or is that already up? Do you have all of the services running?
Yeah, so I believe Logstash is now up and running. We can take a look at the graph view of that. And so here we have a Logstash collection tier that's funneling into a Redis queue, and then a Logstash indexing tier, which then sends the logs to the Elasticsearch clients. And so we took this approach because it's a fairly common and understood way to scale out Logstash. And kind of what it does by putting Redis in between the collection and indexing tier is that it gives you a buffer so that if you're doing something on the Elasticsearch side where you need to take it down, like an upgrade, or you need to do some sort of servicing, or change out your indexers, it kind of gives you that isolation so that your logs can still keep coming in, and you can do what you need to, and then bring it back up and kind of resume without losing your logs. And so this also gives you the ability to kind of scale as you need to. The heavy lifting is typically done on the indexing side, where you're looking at logs and doing, you're grepping through and kind of manipulating data, adding fields, tags, looking for patterns. But that tends to be, where the expensive, resource-intensive stuff comes from. So being able to kind of scale that independently of your collection tier or your Redis tier, has some, cost optimizations for where you're running it and how you'd be running it.
So there are a couple more questions on this setup here. One of them was about what the difference is between the client data and master services and how they're relating. That question was from Andrew Kalik. Do you want to try and discuss that? Just maybe go back and show a little bit about what each service's function is.
Sure. I'm guessing based on the names that we're looking more at the Elasticsearch side. And so I'll bring up the graph view. So the client side here, its role is to service requests from the cluster, and also it's an ingress point to the cluster. Everything in the rest of the stack will interact with Elasticsearch through these clients. And so what this gives us is, you need to scale out kind of your ingress into it, but not necessarily your data nodes, because those are, they have a lot of storage and a lot of RAM, and so you're optimizing those for really the meat of your data, and trying to handle that. You can kind of have smaller instances, and maybe more of them, that kind of handle the client requests. And then the master role in the cluster is really just to kind of understand and know where everything is in that cluster, where the indexes are, where the shards are. And so based on kind of running an Elasticsearch in production system, they recommend that you kind of have dedicated boxes, full instances that are dedicated to each of these roles, so that you can kind of keep the cluster performant and responsive when trying to access the data.
Great. And then another question was, once this is up, can it only handle logs for this specific cluster, or can it handle logs for systems that don't run in this cluster? That was Curtis's question. So once this is up, you could put the agents anywhere, correct, to pull in logs?
Yeah, actually, that's a great question there. So yeah, absolutely. So you can use this just to host the Elk Stack, and then have servers, configure your traditional servers, VMs, and other systems outside, just to talk to like the Logstash collector endpoint. And that's really the only thing you have to expose to those servers. And it's actually how we do a lot of our stuff. We have a load test environment, a latest environment that are all separate systems, but they ship their logs back to a centralized Rancher installation that we run with this stack on it. And really, kind of the neat thing about the way that this is built is, maybe I can just show you a little bit. So this is our infrastructure environment, and what we've done is I've actually created, I have a centralized logging Elasticsearch cluster. I don't need multiple of those, but I have two pipelines that are independent of each other, and so I could scale them depending on the application or need. But also the configuration of Logstash can kind of get lengthy and unwieldy. And so depending on the types of manipulations of the data that you're doing. And so, it kind of gives you that isolation from the configuration standpoint, like it's only really, looking at, this environment and these configurations, so that, it kind of narrows the scope of what you're looking at when troubleshooting or, trying to manipulate it. But also, like, if you're delivering it to another team or organization, you have that isolation so that you can limit their scope and their ability to edit to just their instance, which I think is pretty powerful to teams providing platforms to large organizations.
So this is a question, I think this is a really kind of aligns with the last question. Alex Dersey, I hope I said that right, he was saying, effectively, this is, we're showing now mostly about how to run ELK in Docker, but one of the things he really wants to even if he he already has an ELK stack up and running, how does he get Docker logs into the ELK? Which I think you've shown some of that, but maybe that'd be a good next step in the demo, is to show how you could run a Docker application somewhere else and then pull those logs into Elk using Logspout in this case.
Yeah, that's coming up next in the demo.
Why don't we jump to that?
Yeah, absolutely. So we have a new pipeline, just to kind of clarify. There's nothing still going into our Elasticsearch. Now we need to actually feed it logs. And so I'm a big fan of the Logspout tool just because I think it's pretty simple and straightforward to get up and running, and it sort of handles, there's a Logstash adapter for it that makes it nice and easy to bring up and start sending logs to your Elk Stack. Yeah, so here we'll bring up Logspout. And so what this tool does is brings up, what it does is it listens, you bind mount in the Docker socket into the container, and it then starts listening to the event stream, and then as it sees them creating, it then wires up a listener for the logs, and then it ships them based on these routing URIs. And so what we're telling it here is, use the Logstash plugin and send them to Logstash. And so what we're doing to create that post entry is externally linking it to our Logstash collector. If you were to run this to an external Elk Stack, you would create either a DNS entry, an IP address, or something, but you would specify how you want to ship it here, and then bring that up. And so if we look now, we have our Logspouts. This was a global service, and so what that does is it puts one container on each of the nodes in our cluster. And now if we look at our Elasticsearch cluster, we are actually sending logs to it. We have they've wired up and looked at all the containers, and then you can make it ignore containers by adding an environment variable. But we have a couple different containers running that don't have that, so it's sending those logs over to Elasticsearch, and they're now getting indexed. And that's running through our Logstash pipeline.
So there's a question Ted had that's sort of right on this. Does the setup require that the applications log to the STD out, or can it pick up log files as well via a tail mechanism of some kind?
So Logspout is looking directly at the Docker logs, and I believe this one requires you to do so. If you were to log to like a common volume, you could create a, it's like Logstash Forwarder is a project, or you could run Logstash itself, or there's a couple other variants in Python, there's Beaver. But basically what you would do is you would run one of these agents and point it to a file source and look in that common volume on the host that you've kind of bind mounted everything into, and then you would configure it to forward that data over to your Elk Stack. And so you could accomplish it kind of the same thing that we're doing here with that approach as well. Logstash Forwarder used to be called Lumberjack. It's I think it's Logstash sort of rewritten in Go, and so it's supposed to be a little lighter weight than running Logstash, which is a little heavy on smaller instances. So if you were to just kind of take that approach of running that process to handle it, it ends up being tough to run on like a T1 micro or T2 micro, for instance, or a small droplet. Is that helping, hopefully?
Yeah, definitely. Okay, so we've got the logs are now coming from effectively this. You're basically pulling logs from this cluster you've set up. So you're basically monitoring your existing Logstash thing. What if you deploy an application or something? Can we see that?
Yeah, but before we do that, let's get Kibana up so that we have kind of the last piece of the Elq Stack, and then it kind of gives us another way to see that things are happening. So let's, otherwise it would be kind of challenging to see that the logs are actually going in there. So this last one, we're going to bring up Kibana. What we've done here is we're using kind of the Rancher load balancer to create a VIP, then sending that to an Nginx proxy in between, then sending it to Kibana. The reason the Nginx proxy is in there for right now is that you can add environment variables and configure basic auth. And so you'd have a VIP that then hits the Nginx proxy, which does basic auth, and then forwards the request on to Kibana, so you could protect your data or access or restrict access to your data. So as that comes up, so let's see, we've got our Kibana instance. Go and check out Kibana. So give it a second to do what it says it's doing.
So while that's pulling up, Ted, I think Ted Young was asking if there will be like meetup notes with links to the other tools that Bill mentioned. Ted, we usually send out an email afterwards with a link to the recording, so you can always just kind of go back through the recording and pull which pieces you want. But we'll try to put in links to these compose files that that we've been talking about, and some of the tools if we can. So we'll try and send you links and things like that as much as possible in the follow-up email. So if there's anything though that you don't see in there, just shoot a response, like a question back, and we'll do our best to help you find what you're looking for.
Yep. So right now, this is the Kibana instance that we just brought up. In our configuration, we are sending data to the Logstash demo index. So we type that in after using time series events. And sort of what that means is Logstash is creating an index per day, and that starts rolling over. And so as your logs grow, you'll be able to kind of easily say like, oh, these are 30 days old, delete those indexes and sort of reclaim that space and resources. So that's kind of why it looks like this. So as we create that, we can go to the Discover and see our cluster with our logs are now appearing. So let's make that a little bigger. And so, as Shannon said, let's maybe deploy an app.
While you're doing that, Mike Simos, old name. How would you make a configuration change to one of the containers like logstash.conf or elasticsearch.yaml? Are these baked into the container or on a volume? Would you need to redeploy the container to make a configuration change?
So to make a configuration change, you would create a new service and then run a service upgrade. And so what that would look like, is in one of these configs. So we're using confd, and so these have some very generic templates that look at different keys. So you would, if you wanted to add an additional output, you would basically say that, and then a simple way to do it would be that you want to create a new service, one, and then what you would say is Ranger compose p logstash upgrade Ranger, what is it called? Which one did I edit? index or config one. So log-stash indexer to log-stash indexer to 1. And those were configs. And actually, this config change will. I actually want to do this. So, sorry. When there's a feature that we need to add, that when you make a change to just the configuration sidekick, we need a mechanism to notify the actual service that something changed, so that we would like that service to restart. So right now, to kind of get around that, we don't actually want to do this. I think what we want to do is this. And so I'm going to hope for the best. I have not tested this in a while. Oh. How about that? Okay. And so this does an in-place upgrade of the service. And so hopefully what's happened is now we've created a new service and then kind of updated all of the links and then shut down the old service. And so if this worked, operationally, I don't know if this is actually going to run just because of the configuration I just did. But if it worked, we should see log-stash conf is that we now have, yeah. So we have 2 inputs now, 2 Redis inputs. So a config change would be a service upgrade. What could happen in the future, though, is that you would configure confd to be listening to more. These are currently we're just using environment variables, but you could listen to a live data store, like a rancher metadata as it comes up with user data, or like a etcd or a confd, one of the backends that confd uses. And then if you updated that, the config file would change, and then as we build the capability of having that that sidekick container be able to notify its parent that it needs to do something, that would make this a little more real time.
Awesome. There was so Bill, when you did that upgrade, there was a question someone asked: does the upgrade delete the old container, create a new one, and is the data persisted? I think you talked about this earlier already, but maybe you can just clarify on that.
It currently deletes the existing service and container. You can do it in a rolling fashion, so it only does, as it brings one up, it'll bring the other one down, and then kind of do a rolling. And so, yeah, it definitely it does delete the existing containers. So the data is not persisted. You'd have to persist it some other way.
Got it.
Yeah, which is why in the Elasticsearch instance we're using the host bind mount. The first time I tried to do the upgrade, I learned very quickly that it deletes the container first.
Okay, I think so I think you were going to finish up by adding one more application, so that maybe that's a good way to wrap up the last.
Yeah.
last couple minutes. I know we're already over an hour, so if people need to leave, we are recording the session. Don't worry about it.
I forgot the ghost port. 1 second. All right, so that's on. We'll wire up 8080 to 2368. And create. And if all things are working correctly, that ghost container came up, and we should be able to auto refresh every 30 seconds. Okay. And then hopefully I can look for the word ghosts. And yeah. Okay. It might not have refreshed yet.
So you're starting a ghost blogging server, effectively as a little application on Rancher now, and because the host already has the Logspout, it should start to pull the logs from that tool.
Mm-hmm. Yep.
And then log those basically into Elasticsearch so that we can see them here in Kibana.
Exactly. Okay. Did we get ghost? I promise you this was working.
Did the container come up? I didn't actually see that the container came up, did it?
Yeah, it came up green.
Should be able to see the logs there.
You see the logs here.
All right.
I think if we go here, we have a ghost platform. And are we filtering somewhere? Kibana 4 is pretty new, and I'm still getting used to its differences from Kibana 3. Oh, I probably broke it during that upgrade. That's
someone's suggestion was try ghost looks like. The asterisk is missing when you're trying your search. I don't know if that will help, but.
Yeah. Yeah. I'm gonna stop. Interesting. Start. Bring up the old one.
Maybe your old config when you made the change to the config. Is that what you're thinking?
Yeah, possibly. Scale up.
So while you're doing that, one of the questions that had come in a while ago, I've been meaning to ask it, Hussein asked about it, was you show that you can sort of scale up these different services. Is it possible to scale things down as well? Are you able to, when you need to scale something down, how do you go about doing that? Or is that a little bit more complex because of the config setup?
Yes, you can scale it down. The data nodes at this point would leave behind their data volumes, which is less than ideal. But that's sort of a side effect. The others at this point you could, that aren't doing bind mounts to the hosts, you could scale them up and scale them down. All the links get updated as part of that. And so, yeah, a lot of these right now are currently banking on the round-robin DNS feature that's in Rancher. So they'll hit the ES masters, and if there were multiple, they would get randomized IP address responses. And so as metadata service comes online, we'll bring these up. We'll be able to adapt the configuration, and I think the Logstash one will really benefit from that, where you'll be able to, because when you scale it out, it ends up being a kind of a crazy mesh, and which Redis server it ends up talking to and which queues it's pulling from. And so with the metadata service, I think you'll be able to better or more easily kind of wire that up. So that's something we're going to be improving on as we keep going with this.
Cool. All right. So why don't we? Do you want to check one more time, see if you've got the Ghost stuff working? And so
yeah, I'm going to restart it and see if the logs are actually flowing through.
Get that working, and then we can wrap up this section.
What was someone's suggestion? I'm open to it.
Try Ghost looks like asterisk is missing when you try your search.
Looks like this?
Yeah, I think so. And then like an asterisk, like Shift 8. Yeah. Oh, maybe with the asterisk Ghost. I don't know. You can play with it later. All right. Why don't we jump back over? Bill, thanks so much for going through all this, showing how to build out a scalable Ghost cluster and how to track different logs and being so open to trying lots of different things in the demo. Thanks. So there were tons of great questions that came in. And if you have more questions for Bill, he's not going away. But we do want to kind of hit on a few other things. So we're going to talk just a little bit real quickly on the latest, just the latest news here from a Rancher perspective and some of the changes that have been coming in. I know there are some people that had other Rancher questions. So, Darren, are you still on the call? Hopefully you didn't drop. Darren, are you muted maybe?
Yep, I'm here.
Okay, great. So, Darren, you were going to chat just a little bit about some of the latest, some of the latest enhancements, some of the things we've added recently in the last 3 releases. Do you want to go through this and maybe start with 34 and work your way up?
Yeah. So we've added quite a bit of features, and let's see. I think last time we did this about a month ago.
Yep.
One of the biggest features that we've been asked for since we initially offered authentication into Rancher. Basically, we did GitHub initially, and so people really wanted LDAP and AD integration, and so basically that landed a couple weeks ago. So it's basically our integration is pretty generic LDAP, which also works for AD, but there are some specific things for AD, and so I'll kind of show some of the authentication changes that we've done. I'll demo that just for a little bit. So some of these other things in 34 was a little bit smaller stuff. DNS support for containers on host network. This was like, so we have the ability to, we have our DNS server where we basically do the DNS-based service discovery, and that before was not available to containers that was running on with Docker net host, like the host networking. And so we've made that possible now. It's just through adding a label to the container. You say you basically want to opt in to our DNS management, and we just set it up for you. The proxy protocol support is just making it a little easier to run Rancher server in a production-worthy way behind ELB. ELB has little gotchas with WebSockets, and they don't support it. So in order to really run Rancher server behind ELB, we had to do proxy protocol support. And the last point is the Docker private registry support for Rancher server and agents. This is kind of like a phrase, a little weird. Basically, what this is right now we pull all of our images from public Docker hub, like the main Docker hub. What you now have the ability to do is take those images, do a Docker save, and then load them on the host, or put them up into a private registry, and then use the images from a private registry. So you don't have to go to the internet for images. And so this is kind of like we've been incrementally adding, changing things such that we can run Rancher completely on an air-gapped network. This release, I think, is the very last thing that we need. What we'll be releasing this week, which will be probably 38, I think is the last step to mean we can run completely on an air-gapped network. So that was what was in 34. And 35 was some more major features. So SSL termination for load balancers. Again, that was a very highly requested one. So basically, you can add certificates to Rancher and put them on load balancers, and I'll show that in just a second. And then also our metadata service for applications. If you're familiar with EC2 metadata, like what's available to virtual machines, it's a very similar style. So basically, a container can query through HTTP a well-known address or a well-known location to get information about its environment. So it can discover like what are the other stacks or services or containers in their environment, whether they're IPs. This helps immensely in running like clustered systems and stuff like that in Rancher. Okay, so that was version 35. And 37, we added local DB support for authentication. This has come up quite a bit. Even though we recommend running LD, ADAP, or GitHub, some external system for managing the identity, people wanted, mostly for like demo purposes or just getting Rancher up and running really fast, they wanted support for local authentication. We also added the support for read-only users, so you can specify a user, can log in, see an environment, but they're not allowed to change anything. And the last thing there is just that bump to the latest Docker machine. So, Shannon, if you want to give me control, I'll demo just really quickly. I'll show you some of the authentication and then the load balancer and metadata service. This will be a quick demo, just a couple, maybe 5 minutes.
No problem. You should have it now. While you're doing that, there was a couple questions that came in while you were talking. One was asking about where they can find more documentation about the metadata service. So if there's any docs that you want to show, you can kind of show that there.
Right. So, I mean, all of our docs are on docsrancher.com. You can also just go through rancher.com. So basically, there's a thing here for a metadata service. This outlines basically what's available. And I'll be showing this too, demoing basically what fields and what things are available. Just a word of caution for people using it, the API is versioned, and we highly recommend you use the versioned URL, not like the latest URL, because we very much expect this to change. We just pushed this feature out. We're really testing the usability of it and everything, and so if you continue to use the versioned URL, you'll be fine if we change the format. If you use the latest one, then if we change the format, your applications might break. But we will keep the old format if we add some new things. Okay.
There was another question, and this was a this is a question that there were two people that had sort of asked this question, and I had talked in the beginning just a little bit about the fact that we're going to be supporting Kubernetes in Rancher as well soon, and Cole and Diego asked questions sort of about how that's going to work. So I don't know if you want to just maybe spend a second talking about that, Darren. I think it'd be interesting for people to understand. I mean, we're going to be spending, as we announce this, it'll be coming out in the next few months. So consider this a preview for everyone who's on the meetup. But maybe just anything you can share before we roll that out.
Yeah, we've been working really heavily on this, and should be wrapping up something by the end of the month. The way we look at this is, we've always envisioned Rancher as basically this kind of consistent infrastructure backplane that you basically run anywhere, and then we can run various type of workloads and systems and whatnot. And so, a lot of people might have a preference for running Kubernetes or Mesos or Swarm. There's various different frameworks to deploy applications, and we want to be able to support all those different styles. So Kubernetes, what we're basically allowing you to do is, once you get a Rancher server, once you get Rancher up and running, which for most people it's pretty easy experience to get it up and running. you'll be able to go and pretty much like with kind of like a one-click install, say, okay, I want this environment to now support Kubernetes. And what we'll do is deploy the whole Kubernetes stack, which is the API server and the scheduler, the kubelet, and the etcd server. Basically, all that will deploy the whole management stack and everything you need for Kubernetes. Set that up so it's automatically running. So once that's running, you now have basically Kubernetes running in that environment, and Rancher has visibility to Kubernetes. As you then interact with Kubernetes through like queue control and deploy pods and replication controllers and services and things, the various Kubernetes concepts, you'll see those reflected in the Rancher UI. So you'll see a Kubernetes service come up or a Kubernetes replication controller. You'll then be able to add additional services through Rancher, like load balancing and whatnot, or maybe you want to deploy something through Rancher and not through Kubernetes because of the different things we can do, like global scheduling or whatnot. Our services will still integrate with the Kubernetes services. You'll be able to basically consume Kubernetes from our services. So basically, we're allowing people, if you have, if you like Kubernetes, we make it really easy to get it up and running. We allow you to interact with the system, but basically all the features of Rancher that we provide in terms of like our infrastructure, like our networking, our load balancing, our DNS, all those new storage stuff that's coming, will all work in Kubernetes. And we're just basically plugging in. And so with Kubernetes, we'll also be like rolling out like better swarm support, and then hopefully down the line we're looking at like Mesos 2 and whatever framework you might pop up next.
Great, excellent. All right, go ahead. Why don't you jump into what you were going to show in your demo?
Right. So I just want to go through a show. So some of these, you can see my screen, right?
Yes. Yep. Coming through.
Okay. Great. So I just want to show some of the various changes we did. So before, when you would go into this access control, actually this was before it was up in this menu, but we've actually created this new tab for admin. So because there's actually the admin capabilities are expanding out quite a bit in Rancher, so kind of a whole tab for it. But if you go into access control, before we had GitHub, now we have LDAP. LDAP can be really easy or super hard to configure. Just depends on how complex your LDAP setup is, but basically it's like host name, port, we support SSL. You need to have a service account set up so that we can query things. You need to set up the search base. Like, I basically assume if you're using LDAP or AD, you kind of know these concepts of, what's like the DCs, to set up basically what the, for the most part, like what's like the, whatever, I don't know, actually I don't even know the right term, like the AD route or whatever that you're looking for. But then there's also, if you want to get into really more complicated things, you can specify all of this custom schema information. So I'm not actually going to turn on LDAP, but just showing that's how you configure it. The other one is local auth, which is just super simple. This one I can actually just turn on. Basically, you just need a login name, give it some password, and then enable. So now I've just turned on the local auth. And so once you have local auth on, you can go and you can add more accounts for other people. So
is this just using a database in the back end? I mean, what are you exactly using?
Yeah, so this is just our own database. So we're just saving the accounts into our own Rancher database.
Just a MySQL database?
Yeah, just a MySQL database. We really, really strongly suggest people use like GitHub or AD or whatever. There's a lot more capabilities going through those systems. The primary reason why we added this feature is people want to be able to get Rancher up and running really easily, or they actually are not super concerned about security. But so we still recommend you use like some external identity provider. Like we'll continue to be adding more things like more generic OAuth support, Bitbucket. We have a couple different like authentication systems that we kind of have coming in down the road. So basically, when you add an account, you can select if they're user or admin. So this is actually one of the nice side effects of when we added this feature, is that before, whoever turned on authentication was the admin for the site, and then any other user that came into Rancher was not an admin. Now you can actually have multiple admins, and you can and like if you just go in here and edit, you can switch them to an admin, which then gives people more capabilities to change like the host registration, access control. We're adding a new tab to monitor Rancher itself. You can see what's going on inside of Rancher. Okay, so that's mostly around the authentication things. Now I just want to show you load the SSL, SSL and the metadata just really quickly. So if I go now, when I go and add a load balancer, oh sorry, actually let me go back to infrastructure. So on infrastructure, there's a new tab here for certificates. So you can go and you can add a certificate. So basically, you need the private key, the certificate, and the chain. So this would be, you know, basically like the CA cert and the intermediate cert and things like that. So this is basically you get this information when you request your certs. So I've already added one cert here. This is just a test cert. So when I go and I create a load balancer now, add load balancer, just call it test LB. I'm gonna set up on port 443. I click SSL. As soon as you click SSL, it gives you an option down here. So if I unclick it, you can see it'll say there's no SSL ports. So it'll give me an option. I can choose that cert, and then I can say, okay, we'll go to the Kibana service here, and I should be able to create this service, bring it up. So once this comes up, I should be able to hit HTTPS on this host. This is a test certificate, so it'll give me a warning saying that it's not a valid or not a trusted cert. But oops. Yeah, so untrusted, that's just because I'm using a test certificate. So if you had a real certificate, that would work. Just other thing to point out, we use SNI. I don't know, the service is not available, but that's not the point. So basically the load balancer came up with the SSL. But when we set up the load balancer, basically we use SNI, which means you can set up multiple certificates using different host names. So basically you don't have to have multiple IPs. So you can just set up one load balancer with multiple host names, multiple SSL certificates using one IP and forward to different sites. And then you can do the routing differently based on the host name. So you can have a, kind of like a general purpose load balancer to load balance a bunch of applications. Okay, so that's the SSL. And then the last thing I just want to show you was metadata. So basically,
one question came in from Simone while you were talking about it. Is it possible to configure SSL from Rancher Compose without using the UI?
So right now you have to add certificates through the UI. In Rancher Compose 030, we added support for deploying through Rancher Compose, which is not actually the latest version. So if I click this button and download, I actually get, I think, 025, but we've released 030, but we haven't marked it as latest. Like that should hopefully be done today. And then you'll be able to do it from the command line, and I'll show you what that looks like. I believe it. Oops, not export. Let me just view config. Right. So basically, it looks like this. You set default certificate to the cert name, and then there's a separate parameter where you can say certs, and you can list more certificates. So it depends on SNI. Like if you're using SNI, then you can have a bunch of certs. But if your client doesn't support SNI, they need to fall back to something, and that's what the default search is for. But you'll be able to do this through the Rancher Compose.
There was another question about Kubernetes, unless I think that's all on the stuff. There's another question that came up just about if we're going to be relying on the Kubernetes implementation or our own implementation of Kubernetes, like YAML files. So maybe just talk a little bit more about kind of some of the things that you do in Rancher and how they're overlapping with, this is a question Alex asked, with what's already in Kubernetes. So there's a little bit of confusion about how that's going to work, and whether we're, in the case of Kubernetes, we're using all Kubernetes features or we're using any Rancher features for certain things.
Yeah,
like
so you can see, I think the best way to explain like the Kubernetes is when you look at Kubernetes and you go to install it, you'll see plenty of guides which are like install on GCE or install on AWS or install on DigitalOcean or install on Docker. Like, so basically, wherever you install Kubernetes, you have to set it up a little bit different. And also, you know, because like the networking is different, you know, there's little gotchas with each cloud or whatever. So Rancher basically acts as like a cloud provider for Kubernetes. So once you have Rancher installed, which is really easy to install, it runs on all clouds. We're, you know, very agnostic. It works, you know, works pretty much anywhere. Once you have that installed, you then just put Kubernetes on top of it. So Kubernetes will run wherever you can run Rancher, so it makes it significantly easier to run Kubernetes. So that's one of the, like, kind of the integration approach is mostly that if Kubernetes runs on top of us. And so you're allowed to use full functionality of Kubernetes. We're not wrapping it. We're not changing it. It is just Kubernetes. And the reason why we're doing that is because, you know, some people want to just use Kubernetes. Like, in terms of, like, what is it that you get out of Kubernetes as opposed to what you get out of Rancher, that's kind of, like, negligible. I think it's largely a preference thing. Like, if, you know, you already have some investment in Kubernetes and you like that style, you don't want to deploy things through Rancher Compose, you can go through Kubernetes. So it's kind of, you're just kind of picking which flavor you want.
It may make sense depending on, like, if your applications are already coded to Kubernetes or something, it's obviously ideal.
Yeah.
I mean, or if somebody's giving you a Kubernetes template to launch something from. There's another question about Kubernetes, just about the timeline. When is support expected? And
right. So I mean, so we're finishing up development this month, and then basically we go through like our QA cycle. So you'll start seeing it in RC releases towards the end of this month. When it actually gets released just kind of depends on how much QA. So I would expect like mid-October, but it just kind of depends on, you know, if we hit some major bugs or anything. So far it's going pretty good. So I would say, you know, look at October timeframe.
Famous last QA words. Okay, great.
Yeah.
I think that's everything in terms of inbound questions. Anything else you wanted to demonstrate?
Yeah, it was just quickly, I want to show the metadata. So basically, like I was saying before, like if you're already familiar with, hopefully this works, if you're already familiar with EC2 metadata, it follows the same style. Let's see if I can get a shell up and running. Okay, so basically, hopefully curl is here. No, it's not on my container. Let me find a different container that has curl. That one's Alpine, apparently. This one. That one doesn't like it. Execute shell. That one. Okay. Okay. Yeah. All right. So this one, hopefully, yeah, it has curl. Okay. Great. So curl. So basically, what we do is rancher-metadata. So if we just curl that, you'll see basically you can hit, again, I said you should probably use the version URL just because I know this is going to end up changing. But if you do hit latest, you just get whatever the latest version of the API. But basically, when you hit this, you can see containers, services, stacks. So like if I hit stacks, I can see if here's all the stacks in my environment. If I hit services, you can see those are all the services in this environment. You can go through and basically get, like if you want to know, you know, basically, who am I? Self will tell you what container you are, what host you're on. So like one of the things people have asked, they want to be able to see host labels. Oops, can't put up. So you can say host labels. Does that work? I have no host labels, so return back nothing. But or you can see like the agent IP. So you can get quite a bit of information about the environment just from, you know, hitting these simple URLs. So like if you're writing a shell script or something, it's very simple to interact with this. But if you're writing something that's more programmatic, you know, you're using some programming language, then you probably will just end up getting the whole thing as JSON, and you can just do that by putting in an accept header. You just say accept application oops, JSON. See if that works. Oh wait, there was nothing on host labels. And then you get back, basically the whole structure is JSON. And the nice thing about the JSON approach is it gives you all the children too. So if you want, you can just fetch the entire metadata all at once. And so what Bill has been working on, which is really super awesome, is a conf-d backend for our metadata. So conf-d will be able to hit our metadata, and then as our metadata changes, conf-d can detect the changes, update the configuration, restart the services, and all that kind of stuff. So this is, this is getting, before people had some little gotchas on well, how do I deploy Zookeeper or some of these more complicated, harder to set up clustered systems. With metadata now, it's really made it much easier to deploy these systems, and also to dynamically change as the metadata changes. There's actually, let me just check. I don't actually know. I think it's revision. Shoot, I have to look at the docs. But basically, if you want to know if the metadata has changed, there's a URL that you can hit to find out just what the current revision is. And so if you keep hitting that, you'll see when the metadata changes. So you can end up writing stuff that dynamically changes as the environment changes. So that's basically it. That's the last of the things I wanted to demo. It's what we've recently done.
All right. So I think we answered all the questions as they came in, and that's always a good sign. If we're almost at the end, I think we're about an hour and a half too. So hopefully everyone can see my screen again.
Oh, just one thing I wanted to point out. Bill had said there was a bug with the deploying that stack on Elasticsearch. It's already fixed. So if you run Rancher Server latest, all the templates that he had shown, they're up on GitHub and Compose templates. Those should just run out of the box on the latest version of Rancher.
Great. Last thing, just a couple things. If you want to get a little more up to speed with Rancher, you just visit info.rancher.com/beta, or go to our homepage. You'll see a link to the beta and join the beta. It gives you access to a lot of training and support and contacts, so you can get help as we're going through rolling Rancher out and heading towards GA later this fall. You can obviously just go to GitHub and go to Rancher/Rancher and download it if you haven't ever played with Rancher OS. It's another great tool that we've built, which you may want to try out, or some of the other things you'll see in our GitHub repository. Otherwise, hopefully we've answered everyone's questions, and I really appreciate all the great questions, all the great time. And really, hopefully you've been able to learn a lot. So thank you very much for coming today, and we'll be having our next meetup next month, topicing probably monitoring. So if you're interested in learning more about monitoring, stay tuned. Follow us on Twitter. We'll be posting that as soon as it's ready, and with some content that should be really interesting. So have a great afternoon, morning, night, wherever you are. Thanks.